Hello everybody. In this lecture, we'll discuss about planning in non-deterministic environment in the domain of AI. In this particular lecture, we'll be discussing about the application, and the domain we'll be discussing on the application of non-deterministic planning is in computer games. In an earlier video, we had discussed about the theory, so this is the video for application. So why computer games are important? Let's see this particular data that is presented here. We see that the industry of the computer games is significantly bigger than the music industry or the movie industry as a whole, and we see that it is continuously going at a phenomenal uh, pace that from 2016 to 2020 we see almost a 50% growth of the industry. And if we see the numbers, we see that the gaming industry is bigger than the movie industry and the music industry combined, if we consider the revenue as the parameter. For example, Grand Theft Auto 5, one of the famous and popular games of people play in the console mainly. So this game has recently surpassed the revenue of any movie, book, or music album ever produced. So this is the significance where game has reached today. And with the advent of smartphone and console and sophisticated computers, people are participating in gaming in different forms, and the participation is continuously increasing. And in fact, in this age of pandemic, while the movie industry is almost in this particular year 2020, movie industry is predicted to make a revenue loss, gaming industry is actually booming up. And if we see the statistics, every third person alive is a gamer. So we can understand how much the game impact of computer games has on people's lives. So if we look at how AI has came into the picture of computer games, we see that there are different kind of gaming genre, and people use the methods of AI for different kind of purposes on based on the different kind of genre of the games. For example, in action games, AI is used for modeling human player as the non-playing character or the NPC for game testing. For example, when game is being tested, we want to model how humans will behave when actual gameplay is happening, and we want to make sure that human play do not face certain kind of difficulty or some situation where which is impractical for a human player to actually be able to pass successfully pass through, and actually make sure the game is completable and can be achieved by any human player based on the capabilities of the player, perceived capabilities of the player. So similarly, there are antagonist action. So typically, action games comes with some protagonist who tries to, who is usually the human player, and then the computer controlled characters are there are some antagonists computer controlled, and those actions how based on how human player is behaving during the game, the actions of the antagonists can be basically taken up by different kinds of AI methods are used to actually create those kind of actions, those different kind of actions. And then laws of physics, kinematics, etc. are actually simulated using the methods of artificial intelligence, different methods of artificial intelligence. And in adventure pathfinding, how one person or one character moves from one place to another place, then modeling the human player for game testing, the same thing, the modeling the human player as an NPC. And then in presentation of the environment, how the environment changes based on the whether it is windy condition, whether it is cloudy condition, based on the choices of the player, which kind of adventure the or what stage of adventure the player is playing on. And then story build up, how the story unfolds based on the expertise of the user or based on the choices also. So there are interactive games today where players can actually choose how the game will unfold. In the arcade games, how the environment is presented, how a challenge is generated. In racing games, modeling the competition. For example, someone is driving very good, and usually drives very good, some human player. So but if the player always comes first in a race, probably the game will become boring pretty soon for that player. So in such cases, even if the player is outperforming usual human players all the time, still the program should be able to give fair competition, or I mean, like good amount of competition to actually keep the player engaged. So probably computer program will understand that this player is more playing better than average human player, and will kind of create new competitors, or create, I mean, basically make sure that the non-playing cars or non-playing bikes, whatever is participating in the races, actually all are also taking significantly less amount of time, just to be able to give fair and good amount of competition to this player. Then for puzzle, there is personalization and hint generation at a stage. If player is looking for a hint, how the hint will be generated based on the current game situation. Those are done using techniques of AI. Then in the sports, how the non-playing characters moves, in fact how the human characters are also moving, I mean characters that are controlled by human are also making movements in the game. How players are, for example, if we consider some game of say soccer or football, or some other game, right, where people needs to be placed properly to actually be able to make an impact in the game. The players need to be placed properly. So how the placement happens, or how it is randomized for the non-playing characters, or even to assist the playing characters sometimes. And then what kind of strategy the non-playing characters will follow. If the playing characters, or human characters, are say defensive, then the non-playing characters must be attacking, or they may choose a different kind of a strategy. The kinematics of the player, how the players are moving and acting, and what kind of body posture, etc., they are showing up in the game. Then role playing games, there are massive MMORPGs, like where there are many players playing together in a game. So how those players participate, and let's say a particular game takes at least 100 players to participate in the game. So in such cases, how do we get the game started if one or two human being actually wants to start playing the game? Then all the other 98 characters may be controlled by computer initially, and as and when more and more human players join the game, the computer players will actually be removed from the game, and gradually all the players will be human players. So this kind of filling up positions. In coordination of the npcs, and strategy, what kind of strategy again they will generate. In the strategy game also, the generation of strategy and simulation of strategy. So all these are different kind of applications of AI in the different kind of game setup. So if you want to summarize this into a short thing, and if you want to see how our topic, that is non-deterministic planning, can be actually used in the different kind of gaming. So planning of how non-deterministic planning is used, if we want to summarize: the planning of non-playing characters actions and environment presentation, the creation of the challenges, the generation of the strategies, and build up of the stories. These are the main areas. This is of course not comprehensive, or there is no claim that this is exclusive for different kind of games, are also exclusive, but these are the typical areas where planning is heavily used in the development of the game. And these plannings are based on certain kind of non-deterministic inputs. One of the non-deterministic kind of inputs are with predicted human player behavior, how the human player will behave, or different kind of human players behavior it wants to model with some kind of non-determinism. Then nuances of dynamic difficulty adjustment. So this is a very interesting topic. We'll have a slide for this. We'll cover that there. So then interactive choices of storyline, the point we are referring to, and also game testing requirements. For example, when we are testing the game, we want to make sure the player wants to actually player may be able to complete the game without insane amount of difficulties, or it is playable rather. So, if we look into this topic now, we'll look into different kind of non-determinisms in the non-deterministic planning one by one. So one is the human player behavior profiling. This is like we want to create a model to understand the developers of the game want to create a model to understand what kind of player the human player is, what are the strategies the player is following, what are the tactics, what are the actions the player is taking. And after modeling, being able to model all this, and all these are non-deterministic because the human behavior, tactics, strategies, etc. are typically different, and people follow different kind of weaknesses of the opponents, or takes advantage of different kind of strategies in the game. So some player is fan of basically trying to do lot of say in action games, lot of fighting and everything. But there are players who want to play it in a stealth mode, and they do not want to engage with the opponents quickly. So they want to so these are two different kind of strategies. I mean, there are many final level of strategies as well people follow, and the players follow, right? So all these are analyzed, and then based on that the game environment is actually changed by a program. So this is where the application of non-determinism and how the game environment changes is the kind of planning that has to be done upfront during the development of the game, so that all this can be actually taken as input to the game. And why we do that is the topic of dynamic difficulty adjustment, where the idea here is that different kind of human players with different levels of skills or experience, or different kind of dexterity, or their thinking or strategies, right? So we want to make sure the game development companies want to make sure that the game is not boring for any of them, right? The game has to be like equally enjoyable and challenging for each of them. But that exactly means that for different kind of players the game cannot be equal, or game cannot be exactly identical presentation of the game to all the players. So how do we cope up the situation? We want to make sure that the player who is we want to pose the challenges of the game in a way such that player neither feels bored nor feels anxious. So when a player is the game is very easy for a player, the player will feel and bored, and so when the game is very difficult, the player will not be able to make progress, and then also user will not actually keep engaged to the game, right? So we have to basically create a middle lane which is called the flow channel, and we have to see that how the game can be actually moved through this flow channel, so that we always keep a balance between the levels of anxiety and the boredom of the user, so that user is engaged in the keeps engaged in the game, and actually plays the game. Because the more user plays the game, the player plays the game, the more profitable the company usually is. So so this dynamic difficulty adjustment basically works like profiling the user's behavior, and based on that in the game is dynamically changed. The challenges, the environment, the strategies, or non-playing characters behaviors, all these are changed based on the human players behavior, and this all happens dynamically. So to be able to do this dynamic adjustment of the game, it requires upfront planning, and the planning of course has to have non-deterministic components in it, because different humankind behaves differently. Um, the third aspect which was interesting was about how interactive choices of storyline actually changes the basically presentation of the game, or the unfolding of the game to the player. So for example, here is an example of Near Automata is a game where it says that offering multiple endings depending on the actions and choices of players. So these kind of games are gradually becoming very popular. In fact, there are movies also now in this form, where people actually the viewer can choose what kind of ending or what kind of unfolding of the movie will happen. So these all came from this concept of interactive choices of storyline. And here also we need upfront planning of the game based on the non-deterministic choices that user can make, or sometime it may not be non-deterministic, but the choice could be a very large deterministic set. So now, having seen all this, let us try to test a game. So what we can do to understand how non-deterministic planning is used in basically to decide the outcome of NPC's actions. Let us try to do something. Let us try to create a game framework or describe a game framework where we can actually test a game where the NPC's actions have some non-deterministic outcome, and we want to, as a developer, we want to test the game so that we want to ensure that when this NPC is actually replaced by the human character, so that basically the human is playing the game rather than computer controlling the character, the human is controlling the NPC character, uh, then it doesn't remain NPC anymore. So that time, whether the human player has any kind of difficulty, or what kind of difficulty, or how much difficulty the player will happen, that is what we want to test. So in this game setup, we'll have a world, a simple world 3 by 3 block. He's a character specifically designed for this particular lecture. The name of this character I've given is Dario. So, so we'll see what Dario will do in the game. And there are some coins, silver coins, gold coins, and there is a roadblock. So this roadblock means if there is a roadblock, the block as if does not exist in the game. So, and there is a home. Where we'll see how these components will come into the picture of the game. These are these elements. So as I said, I mean, in this testing phase of the game, Dario is an NPC modeling moves. Dario basically is an NPC modeling moves by a human player. So there is no human player here. In the real game, Dario will be controlled by human. In this particular testing phase, Dario is being controlled by a computer. So we are trying to model that, and we want to make sure we want to test certain winning conditions. So we'll see what kind of winning conditions we want to test. So let us describe the rules of the game now. So Dario will be placed, Dario block, the home and the coins will be placed on different or random places on the board. So here it says that the objective is that from the initial place of Dario wants to reach to the home, the block where the home is. There will be a single home, at least for this explanation of this particular lecture. And this is, by the way, a made up game I just made up for the part of this lecture. There is no I mean, I have not taken this example of game from anywhere. So the idea or the logic or whatever is just made up. So from 1 1, Dario wants to go to 3 2 in this case, the cell 3 2 where the home is, because Dario wants to reach the home, and there is the winning case. But on the way home, Dario wants to collect the coin, one of the coins, because Dario has only one pocket. If you see, there is a small square, I mean, this white square there. So this is a small pocket where Dario can carry one coin. So there is a gold coin, there is a silver coin, and the gold coin has some value, silver coin has some value. The value of the gold coin is more than silver coin. Dario wants to make sure that he carry, basically Dario will always want to carry the higher amount of coin. That is the objective of the game. And be able to reach to the home. So reaching home is the winning condition, but to improve score has to collect the high valued coin. So this is the game setup, and of course Dario can move from upward, downward, leftward, or rightward. Cannot move diagonally on the board. This is pretty standard for we have played. I think all of us have played this kind of simple games, and Dario may, this is one additional inclusion, or we can say exclusion in the game, that Dario can actually be on a say for example in this particular figure, Dario can be on the 1 3 cell on the silver coin and still not collect the silver coin. So collect is the explicit action by which he will collect if some, but Dario may choose to pass through a cell where there is a coin, and then Dario can actually not collect the coin, or collect the coin based on the choice that makes. And when coin is collected, if earlier some coin was collected, the old coin actually vanishes. So for example, Dario first collects the silver coin and then comes to the gold coin and collects the gold coin, then the silver coin will vanish. This is the setup. What you want to test in this particular setup is you want to test that Dario will always win. So there has to be a plan that Dario can always win. So our test approach for this testing is, we'll create a plan to lose so that Dario cannot reach home. And if no plan can be created, then the testing objective is satisfied. So let's try this first. So the predicates of the game, if we want to see in terms of how planning is done, so their predicates are Dario at 1-1, home at 3-2. So Dario at, home at, block at, where the blocks are placed 3-1 and 3-3, where gold coin is placed is 2-3, where silver coin is placed is 1-3. What are the sales? So the sales of the board are 1-1, 2-1, 3-3. So all these are the sales. And then Dario has silver, Dario has gold, these are the additional things. Dario doesn't, of course, at this state of the configuration of the board, Dario does not have silver or gold, but these are the two predicates. I mean, Dario has a predicate which can say silver or gold. Then let us look at the actions. So this is the initial setup of the game. In the start of the game, we are just setting up the board, Dario's position, the position of the home block, and the gold and silver coins. And we are also saying that Dario does not have gold and silver. So this is the initial setup of the board. Then there are three winning conditions. So one winning condition I already described is that if Dario reaches home is a win. We are calling that a win okay. That Dario does not collect any coin and just goes to home without any coin, that is win okay. So it's a okay kind of a win without any good score. Then if Dario collects a silver coin and then goes to the home, then it is a win good. And we'll see that if Dario does not have gold and has silver is the precondition for that. And the effect is win good has happened. Right. So basically no effect. So it is a result is win good. And the win great is that when Dario actually collects a gold and does not collect silver, and then basically collects the gold and goes home, that is the win great condition. So this is the best kind of win with the highest possible score. So and then Dario will lose if Dario there is a block here, Dario cannot go to home, and there is only one situation Dario cannot go to home is if there is a block here. So basically reach all the way to reach the block, reach the home is blocked. And in this particular setup, initial setup of the game, if these two already placed blocks are not movable, then having another block at 2-2 position will basically pretty much seal the all the paths to reach the home. So that is we are calling as a lose condition, that Dario is not at 2-3 and not at 3-2, that is the home. The home is at 3-2, Dario is not at 3-2, and there is a block at 2-2, there is a block at 1-3, there is a block at 3-3. So all these are satisfied. That means Dario cannot actually reach the home. So this is the losing condition. Then move right and move left is pretty simple. I mean, Dario has to be at cell ij to be able to move to I plus 1j, and there has to be a cell at I plus 1j before move. So the cell at I plus 1j has to be true, and there has to be no blockage. So that if there is a block, Dario cannot move to that cell. Similarly, we can create the move up, move left, and move down, all these different kind of movements. And the effect of this action is, of course, Dario will be at that cell. Then collect gold or collect silver are similar. Dario has to be on that particular cell where the silver or gold coin is. So in that on that particular cell, and then on that particular cell, gold has to be present. So this is the collect gold. So gold has to be present. And Dario does not have silver. So because Dario is collecting the gold now, so if Dario had silver, we have to make sure that it does not have the silver anymore. So Dario does not have silver. Dario has gold, and there is no gold anymore at the cell ij. So now let us look at the few possible plans, because our objective is to find a plan to lose, and if we do not find that, we'll say that our testing objective is successful, that there is no plan to lose. Of course, we see that under the current setup and the rules of the game, we see that there is no path to lose, because there you can simply go from this 1-1 and just move, take this path, for example this path, and reaches the home. So basically that is a win okay. There is no losing here. Another possible plan is that from the start Dario actually moves to the right, then collects the silver coin, and then comes back to the home. That also is there is no failure. Then we see that instead of collecting the silver coin, Dario goes to the gold coin sale, collects the gold coin, comes back to the home, goes to the home. That is also not a failure. So practically there is no condition where it can fail, because there is no blockage at 2-2 and no other blocks are movable or anything. So we see that there is no possible way to lose. So our test conclusion is success, that there is no way to fail, no way to lose. So but the point here is that what is the point of discussing all this, because there is no non-determinism here. So let us introduce a non-determinism. So we have now reached at the level 2 of the game, and as a developer we want to test that. In the level 2 there are certain changes or additions of the rules, and we want to ensure that our new testing objective is fulfilled with the additional constraints. So what is the additional constraint in the level 2? That when a coin is collected, a new roadblock may appear. So this is the non-deterministic part, because it may or may not appear, and in one of the four non-diagonal surrounding blocks. So one block may have at most four non-diagonal blocks. For example, the 2 2 here, it has four non-diagonal blocks surrounding it. So a block, if a block had a coin and that coin is collected in one of the surrounding four non-diagonal blocks, a new block may appear, blockage may appear. So blockage, roadblock may appear, and it may or may not appear. And what is the probability of a roadblock appearing? Is that it does not appear, or it appears in all the free cells. So free cells here means that the cell, for example, in this particular case, if we consider the gold as the particular coin that I will be collecting, then under this condition our blockage may appear at this cell, only this cell, because blockage may not appear at a silver coin cell, because the silver coin is not a free cell. Block here is a roadblock, it is not a free cell also. So only possible way, and there is no block on the right hand side of this gold coin. So essentially there is only one spot or one cell where particular blockage may come, new blockage may come, and this one is half the chance, and the other half of the chance is no blockage will come. So that is the, so basically all the free cells plus the all the options, and the last option is no blockage will come. So all these together, it has equal probabilities of having the blockage. So now our testing objective in this level 2 is that there should be at least one solution with chance of win rate greater than 60%, which means that Dari will collect the coin, gold coin, and go to home. The chance of that, there has to be at least one plan, so that the chance of that happening is excuse me, so the chance of that happening is greater than 60%. So that is the testing object. So we want to make sure that the game has certain amount of easiness in that, so that, and player also, a new player, only this is only level 2, so the player feels comfortable enough to ensure that the to collect the gold coin and score maximum and go home. So we want to make sure at least there is one plan like that. So the approach here is that we'll generate all the plans with all the non-deterministic choices. So here the non-deterministic choices is whether the block will appear or not appear based on Dario's actions of collecting the gold coin or the silver coin, and we'll evaluate the win rate chance of each of the plans, and we'll see how it actually turns out to be. So let's look at the first possible plan. So plan 1. In this plan, we the objective is like we'll see whether if Dario does not collect anything and goes straight to home, what is the chance of win rate. So we see that of course Dario has many possible ways to not collect the coin and go home. So all these are possible ways. Without collecting coin, also Dario is passing through silver and gold coin but not collecting the coins. So there could be more, in fact there could be loops or something. I have not shown all those. It's a simple paths without repeating, basically going back to the same node again and again. All the simple paths here that Dario can take to actually reach to the home without collecting the coin. And we see that of course here it is only one win okay, because it's not collecting any coin, so chance of win rate is 0%. And we see that we say that the plan 1 is a failure, test conclusion is failure, because the win rate is 0%. It has to be at least 60%. That is our objective. Let's look at the plan 2. Here we'll see how, if we collect the silver coin and go to home, what is the chance of Dario actually having a win rate of greater than 60%. So there are two choices here. These are the non-deterministic choices, and I remember from our theory class that we actually can represent this as an AND OR graph. So these are the choices of basically evaluation of both the nodes. These are the AND choices. Both of them has to be evaluated to be able to actually take a decision at this level. So So we see that okay, there are many possible ways that Dario can actually go and collect the silver coin. So these are all the ways, non-repeating ways where Dario does not repeat cell in the path. So all these ways that Dario can reach at the silver coin and collects the silver coin. Then these are all the paths, and there are two choices basically two outcomes. One is when it collects the silver coin, nothing happens, so no extra cell comes, and here is an extra blockage comes in this particular cell, so roadblock comes. So these are the two choices. And is there any possibility of a third choice? No, because there is only one non-diagonal free cell, because here this is a non-diagonal cell but it is not free because it has a gold coin. This is a non-diagonal cell and it is free, so that is why here a blockage may come. So these are the only two possible outcomes if Dario collects the silver coin. After that, if Dario wants to go home, in both the cases we see that Dario has a way to go home. So basically it can go home easily without any difficulty after collecting the silver coin. So win good, both are win good because both cases Dario has collected the silver coin. So win rate is again 0% and our plan 2 is also a test failure. Now look at the plan 3 where if Dario collects the gold coin and goes home, because this actually makes sense because we want to have a win rate, and win rate wants that Dario collects the gold coin. So the previous two are kind of trivial testing, but let us see what happens now under this strategy of collecting gold coin and then go home. So Dario collects the gold coin first and then basically um, um, there are two possible outcomes. One is that nothing happens, and the second is that there is a road blockage comes at the adjacent cell. So again in this case also we see that there is only one possible roadblock that can come, no other non-diagonal cell is free. So there are two choices, and for the first choice we see that Dario can actually go home, and for the second choice we see that Dario cannot go home because there is a road blockage happened at 2-2. So in this case there is a lose, in this case there is a win rate. So the chance of win rate is 50% and losing is 50%. So again our test is a failure. So at this point is it it may appear that so basically even collecting the gold coin and going back to home is not worth it because chance of win rate is still 50%. Let's try to see if there is any other plan that we can generate to actually increase the chance of win rate. Let's try to plan the way that we first collect the silver coin, then collect the gold coin, and then go home. So let's see what is the chance of win rate in this case. Intuitively the chance of win rate should be less because after collecting the silver coin some additional blockage will come, and that may actually reduce the chance of being able to go home and lose the game because there will be less number of paths for the Dario to move. But let's see what happens, whether our intuition is correct or not. So first we'll collect the silver, Dario will collect the silver coin, and again we have seen these two cases earlier. And for the first case, after that if Dario collects the gold coin, we see that there are three possible outcomes now, because now there are two non-diagonal cells that are open. So this one and this one. So these are the two cases where the first case where the case where there is no blockage, new blockage is coming because of collection of the gold coin. Second case is one blockage has come here, and third case is one blockage has come here. So we see that in the third case it is a lose. In the first case Dario can actually go home, and second case also Dario can go home with the gold coins. In both the cases the win rate is basically all this has equal probability, so 1/3 1/3 1/3, and this is a choice of 50% choice chance of nothing happening and 50% chance of silver coin. So basically on this 50% we have three choices, so that's why 16.66% for each of the win rate and lose. In the second path, when Dario collects the silver coin, we see that again there are Dario collects the gold coin. We see that again there are three possible outcomes, the same as before, but here we see that there are already some blockage previously because of collecting the silver coin. Now new blockage has come which prohibits Dario to actually go to the home. Then no blockage come, this is the second case, and the third is another blockage comes at this cell. So again, we see that from for the first case, that you cannot go home, but for the second and third case, that you can go home with the after collecting the gold coin. So being able to go win rate is again 16.66% and 16.66%, and losing is 16.66%. Effectively, our total win rate is combining all these four is total 66.66%. And bingo, this is a situation where we can actually say that our test is success, because our chance of win rate is greater than 60%. So although it seemed initially intuitively, it seemed that there is no way to actually get that kind of a plan, but there is a plan. So this game is not that trivial also, as we thought in the beginning maybe. So this is how we see that how a non-deterministic planning can help in the development phase of a game to model a human being's movements by an npc character, and be able to see whether the winning conditions are or the expected winning conditions are met by the or satisfied by the movements or actions that can be chosen by the all the possible actions that can be chosen by the human player. So this is how non-deterministic planning, one example of how non-deterministic planning is used in computer games. So these are the references that we have used. Thank you.